In today's topic, let us discuss about DOL Starter. A DOL Starter is also known as Direct Online Starter or Across the Line Starter. If someone asked you in the interview what is Across the Line Starter, just tell them it's a DOL Starter. In a DOL Starter, an induction motor is connected directly across the three-phase supply. That is, if you assume this as RYB phase, that is RYB, and the induction motor is connected directly across the terminal. There is no interruption of power. It is connected directly to the supply. That's why it is called a direct online starter or across the line starter, because it is connected across the lines. As it is directly connected to the supply, the dual starter applies full line voltage to the motor terminals. If you assume this is RYB, as it is a three-phase supply, you get 415 volts in the main line, and the motor, as soon as it is connected to the supply, it receives a 415 volts. It receives directly 415 volts. The dual starter applies the full line voltage. 415 volts is directly given to the motor in the starting. The dual starters are used for the motors having low power rating. This is a very important point. The low power rating means the motor should be below 5 HP. This is because of inrush currents. Now, what is inrush current? I will upload another detailed video on this topic, but in short, the inrush current means the motor takes 3 to 4 times its full load current. That is, if a motor is rated at 5 amps, the motor's full load current is 5 amps, it takes 3 to 4 times more current in the starting. This 3 to 4 times more current is called inrush current. As soon as the motor is connected to these terminals, the motor starts taking high inrush current. So if the motor is above 5 HP, the full load current of the motor is very high. In the starting, it takes more than the full load current. So a significant voltage dip is created across these terminals. When the current suddenly increases in the starting, a huge voltage drop is created across the terminals. If the motor is above 5 HP, the inrush currents are more, so the voltage dip is more across the current. So we do not use a motor above 5 HP. In dual starter, dual starters have high starting torque, because we all know a simple equation, that is torque is directly proportional to the current. So in the starting, we are not limiting the current sent to the motor, so the torque is obviously high. So dual starters have high starting torque. Now let us see the power circuit of a dual starter. Every starter circuit has power and control circuit. Control circuits. Every motor has power and control circuit. Let us not make this video lengthier by discussing both power and control circuit. I'll make another video in which we will detailedly discuss about power and control circuit. Let's go back to the topic and see only the power circuit of a dual starter. The main components of a power circuit in a dual starter is a 3-pole MCB. This diagram represents a 3-pole MCB. And these are 3 fuses connected across the 3 lines, that is F1, F2, F3, and this symbol is known as overload relay, simply OLR. A overload relay is nothing but giving protection to this 3-phase motor. After the OLR, we have a power contactor, that is C2. As soon as A1, A2 get energized, the contactor get closed. When you close this MCB manually, the power starts flowing from here to directly to the motor. There is no obstruction to the flow of power. This is the circuit of a motor running by DOL starter. The motor is directly connected to the supply. So this is the power circuit of the DOL starter. You might have a question how A1, A2 is getting energized. This will control by the control circuit. I'll definitely explain you in another video. Let's quickly discuss about advantages and disadvantages of a dual starter. Advantages of dual starter: it is simple, most economical starter. That is, it's simple, it does not have much complex circuit, so it's very simple and most economical. Easy to understand and easy to troubleshoot. Provides nearly full starting torque at the starting, because We are not limiting the current in the starting, so we are getting full starting torque. The design, operation and controlling of the starter is very easy. Now let us discuss the disadvantages of DOL starter. It has high starting torque, but not every application requires high starting torque, so it might be a disadvantage sometimes. DOL starter reduces the lifespan of the machine. How can we say DOL starter reduce the lifespan of a machine? Because of the inrush currents. At the time of starting, the motor receives very large amount of inrush currents. The windings of this machine receives the high current. If the current is high, I square R losses increases. So the winding gets heated up. So it reduces the lifespan of the machine. Important point. I have told you before also, it creates a significant dip in the voltage and is suitable only for small motors. If the motor rating increases, the dip in the voltage also increases. So that is a big disadvantage of the motor end. Remember, small motor here indicates below 5 HP. A very important point. That's all for today's video. This is Sandeep Shakri signing off.